All right, gentlemen, today we're going to be talking about conditional statements. I want to apologize in advance. This video is probably going to be slightly longer than normal, but I will also say that conditional statements and this type of work is some of my favorite topics to talk about. So this is something that I really like, and I think that you guys will like. A little bit of logic, a little bit of puzzle type stuff, really fun. So, conditional statements, let's write this here statements. All a conditional statement is an if then statement. So, it's just an if then statement. So, if I am hungry, then I eat dinner. Something like that. We'll go through a couple examples today, but let's get through a few more of the notes. Then we'll talk about symbols and what it looks like on a diagram and that sort of thing. So well, let's go ahead and start with notes. So this is going to be our conditional statement. How we're going to talk about, and the way that we are going to read it. We read this as if P then Q. So if P then Q. Or we could read it as P implies Q. We could say P implies Q, but that's something that I don't typically use a lot, and I don't think I will. So we're just going to stick with the if P then Q. And then over here I have just a small little diagram. So if P then Q. This basically, what this diagram says is that if P happens, if this event P happens, then Q happens. So for example, if I eat dinner, then I'm not hungry. So P is the if I eat dinner, and Q is the then I'm not hungry. But there are also tons of different ways that I could become not hungry. I could also eat breakfast. I could also eat a snack. I could also eat lunch. So all these different things. So that's why the P is smaller than the Q. And this is part of a Venn diagram. Typically we see Venn diagrams and they look like this, where there's only a crossover in the middle. This crossover is basically anytime there's P that there is Q. The other thing that we can draw from this, and we'll see, is anytime that there's Q, there's not P. So let's talk about the hypothesis. So this is the P. And this follows the if. And then the conclusion is the Q, and it follows then. So this is the Q. So this is really important anytime if you're, talking to me, you're looking in the book for some extra help, or you're, looking at more resources, it's going to use P and Q. And that's kind of a standard thing. It's what I use in college. It's what the book uses. It's a very standard thing. The next thing that I'm going to mention is this truth value. So this truth value is basically whether a statement is true or false. And it's most commonly denoted as T or F. We usually don't write out true or false. And you'll see once we get into some charts, and you'll see how the true and false kind of falls into that. Now the negation of a statement it basically negates it. So it's saying, instead of saying the sky is blue, it'll be the sky is not blue. So if I say P is equal to the sky is blue, the negation of P, which is denoted with this symbol, is going to be the negation of that. So the sky is not blue. I'm going to Google this really quick, because there are other symbols that we can use for negation, and I know negation, conditional. I just want to make sure that you guys see a little bit of everything. There's one other. There it is. So the other way you could say it is, or write it, is like a little tilde. I will always use this. I like it more. It looks cool, and you don't get to use that at all ever in math. So I will use this little negation symbol. So all that means is it's negating whatever the sentence is. So now we get into how we can look at a statement. So a statement. So, I'm missing a note here. So the first thing that we're going to talk about is the conditional. And the conditional uses the given hypothesis, and conclusion. So for this example that we are going to use, we are going to be talking about an angle. So if measure of angle A is equal to 15 degrees, then angle A is acute. So our hypothesis, going back up here, our hypothesis follows the if. So our hypothesis is here. So this is kind of our P. And then our conclusion is this. This is our Q. And then once again, the way we do this in symbols, P then Q, P implies Q, either way. We call it if P then Q. I'm going to try to use colors a lot to help the understanding of this, because it does get a little bit confusing. So the converse, it swaps the hypothesis and the conclusion. So now we're saying if angle A is acute, then measure of angle A is equal to 15. And you might say that this is not necessarily always true. What about if angle A is acute, then measure of angle A is 6 degrees. That is true. These conditional statements, the converse, the inverse, the contrapositive, all this stuff down here, they don't necessarily have to be true. So just different ways that we can change the statements. So once again, we have our P, we have our Q. Let me, I messed this up. So the P's and Q's, when we're writing the converse, the inverse, and the contrapositive, when I ask you to write those forms of the conditional statement, they're going to change. So it's Q, then P. So this all goes off of our conditional. It goes off the conditional. So this conditional statement is what our converse, our inverse, and our contrapositive go off of. So I apologize for that. So now we're saying Q then P. So if Q then P. So our inverse now, it negates both hypothesis and our conclusion. So what this looks like is we take our original and we're going to negate both of them. Well, we could do it like this. If measure of angle A is not 15, then A is not acute. So we're going to have the negation of P. The arrow implies the negation of Q. And we read this: if not P. So not is the negation. If not P, then not Q. So that is our inverse. And lastly, our contrapositive. So now what we're doing is we're going to negate both hypothesis and the conclusion of the converse. So we're going to take our converse and the sentence that the converse makes, and we're going to negate it. So once again, go is not acute, then they do not, then our measure does not equal A. So now we have not Q, not P. We have our implies, or the if then in the middle, the arrow. So we read this: if not Q, then not P. So this is all our first time taking a look at this, and just to make a note, now that I really think about it, this is going to take some time. So there will be no quiz on Friday. Not only do I think it takes time to get used to this sort of thing, the language, the inverse, the converse, the contrapositive, all these things, and practice with each one of them. There's also so many questions that are really cool that I want to ask. So I would not expect any sort of examination in this week. Next week, more than likely. Now, anyway, let's finish up. So equivalent statements are statements with the same truth value. That is it. And that is using our truth value up here saying whether a statement is true or false. So two statements are equivalent if they are true. And two statements are equivalent if they're false. So using our same example, we could have conditional, or the conditional. Conditional, the converse, the inverse, the contrapositive. And your truth value, or our example, is going to be our sentences that we used up here. If I could copy them. And these are, and we'll talk about it, these are things that can be disproved with a counterexample. Come on, go smaller. Whatever, this is good enough. So, if our measure of angle A is 15 degrees, then A is acute. That's just a fact. Anything less than 90 degrees is an acute angle. True. So if A is acute, then the measure is 15. Well, that's false. I said, we could have angle 6. Now, if the measure of angle A is not 15, then angle A is not acute. So this is also false. Once again, what if we have angle 6? If the measure of angle 6 and it's saying that this is not acute, that's not true. That is an acute angle. And then lastly, if angle A is non-acute, then angle A cannot equal 15. And that is true. That is true. If it is not acute, meaning it's greater than 90 degrees, it can't equal 15. So that's true. So we see that these two here, these two truths and these two falses, they are equivalent statements. So equivalent statements, and then the same thing here. We got equivalent statements. Now there's a lot of different things that we can go over. I think it's best to leave some of these for class, and I go over 3 or 4 of these, talking about them, going through them very slowly in class. We have this acute and measure 15, which I think is a good example, but we need to see a little bit more. So we're going to do the rest in class, and I'm going to make up a worksheet, which is going to have a lot of hand-picked problems and stuff that I like, some easy and some very difficult. And there's also just a lot more in depth that this goes. We're going to be making something called a truth table, which is something that we'll talk about. And we have conjunctions and disjunctions, and then we have laws that go along with all these things. So this is going to be a quite the extended look into all this. I will say, if you guys want to take a look at anything, this is on page 89 of the book, and I have the book I used in college is something that I really, really, really like. It's my favorite math textbook that I've ever looked at. If you guys were looking for maybe a little more or help, I'll let you, or maybe I'll post some pictures and stuff like that. So if you guys have any questions, please let me know. Remember, I'm available before school, after school, and during school upon request, and upon upon request, just make a meeting and we'll work something out. If you guys are still worried about your grades, I think I'm going to send something to all of your parents, just saying, hey, look, if your student's grades not good, the reason why is they might have bombed one test, but that's okay. We got plenty of time to make it up. So